Okay, everyone, we're just going to the Cambridge booklet, exercise 5D, Binomial Theorem. Just remembering that the general term of the expansion a plus x to the power of n, so the general term is the k plus 1th term. It's n c k, a to the n minus k, x to the k. The main thing is that the x, notice it's the second term is to the k and the first one is the n minus k. And the second term, its power is the same as the nc, this k here and that one are the same. You don't want to get it the other way round. Do you know what I'm saying? So nck, a to the n minus k, x to the k. Just some examples from Cambridge. So example 1. Find the general term. Now, what we're doing general terms today, but we're manipulating them. So find the general term in the expansion of 2x squared minus x to the minus 1 to the power of 20. That's part A. So find the general term in that expansion. Part B will be then to find, we'll do part B and C in a minute. Okay. Find the general term in the expansion of that. So what would it be? This is an example. Just example 1. So what would it be? I'm just going to write general term, but you can write t to the k plus 1. So the general term is, isn't it 20c k? You'll notice in Cambridge, I think they use R for their general terms sometimes, or J or I or whatever, it doesn't matter. 20ck, what do I do now? Look at this, it's 20, it's whatever your power is, ck, it's your first term to the power of 20 minus k, and it's your second thing, your second term. Now the second term happens to be a negative. So you go minus x to the minus 1 to the power of k. So girls, just be careful here. If you've got a minus in the middle, your second term will be in the negative, because this is of the format a plus x to the n. A is the 2x squared, and x in this case is negative x to the minus 1. Yes? Do you want me to do an easier one first? This is not that hard. This term is 2x squared. And x, your second term, is minus negative x to the negative 1. 20ck. What we need to do here, we've got 2x squared to the power of 20 minus k. We need to break it up. So we've got 2 to the power of 20 minus k. What do I write now? Because 2x squared is 2 times x squared. Times x squared to the power of 20 minus k. What would I get here now? Now, I want to do the same here. I'm going to break this minus x to the negative 1 up into times negative 1 to the power of k. Okay, so notice how I've done the coefficient of the x squared. I've gone 2 to the power of 20 minus k times x squared to the power of 20 minus k. I'm going to do the same thing here. I don't want negative x to the power of negative k. I want, there's a negative 1 is the coefficient of that x to the minus 1. So I want negative 1 to the power of k times x to the minus 1 to the power of k. So I'm breaking those up. Do you need it bigger? Wait, I can't really go much bigger than that. Okay, which is equal to 20ck, 2 to the 20 minus k. What else have we got? What I want to do, I want to put all the coefficients of the x, anything independent of x first, constants. Girls, 2 to the 20 minus k will end up being a constant at some stage, because k is a value between 1 and 20, or 0 and 20. Okay, so this will just be a number. Negative 1 to the k is just will be a constant depending on the value of k. And I just want to put, so what I've done, I've broken up any numbers, because there are 2 things here to the power of 20 minus k. I've broken them up. This really is negative 1 times x to the minus 1. The coefficient needs to be the power to the power, and so does the term. Okay, both to the power. So this will be what? X, I want to expand this, 40 minus k times x to the, thank you, 40 minus 2k, good. Oh, so I just fixed that up. So that's x to the 40 minus 2k times x to the negative k. Now, the main thing here we're going to be doing, anyway, we'll just keep going. These types of questions generally get you to look at the coefficient of those x terms. So what do I get here now? X to the 40 minus 2k plus minus k is 40 minus 3k. It's 40 minus 2k plus minus k is just minus k, is 40 minus 3k. So that is a simplified general term of that expansion. So if they do ask you to find the general term, you don't just write out the first line. You need to break these up and do the general term like that, where this bit here at the front is the coefficient of the general term, and this is your power of x. Because look, when you do a binomial expansion, such as this, you're going to end up with something x to the 10, something x to the 5. You'll have a coefficient in front with an x to the power of a number, okay? Okay, now this is any general term. So, for example, if I want the fifth term, for example, let's say I wanted the fifth term, what would I substitute for t5? K is 4. Yeah, so if I wanted the fifth term, I would substitute in k is 4 here. All right, but I'm not doing that right now. All right, so that's our first example. Why do you think we've got an x to the power of 34 when the highest power here is 20? Because you've got an x squared here. So you could even go up to x to the 40. X to the 40 would be your first term. All right, so find the term in x to the power of 34. If I want x to the power of 34, notice this is my coefficient, that's my x term. So for the term, so to obtain term in x to the power of 34, what equals 34? 40 minus 3x, that's it. 40 minus 3x is equal to 34. And just solving that, we get that 3x is 6, in other words, x is 2. So to get the term in x to the power of 34, it's a k. Thank you, it's a k. I'm a bit off today. K is 2. So k is 2 gives me the term in x to the power of 34. So hence, the term in x to the 34 is going to be, I substitute into this general formula. It's 20c what? 20c what? 2. 2 to the 18, negative 1. We're substituting k is 2 here. Negative 1 squared, x to the 34, obviously. Now, sometimes they'll ask for the term in x to the 34 or the coefficient of the term in x to the 34, of x to the 34. You will do these all the same way, where you come up with a simplified general term where you've got anything independent of x at the front and your x term as one term here at the end. If you want the term in x to the 34, you make 40 minus 3k equal to 34. If you want the term in x to the power of 5, you make 40 minus 3k equal to 5. If you want the term independent of x, you make 40 minus 3k equal to 0. Okay? We'll do one of those in a minute. Okay, so now what do? I simplify this. So 20c2, what's the formula for... I want you to do it using factorial. No. Well, all right, I suppose you could, but let's just practice. What is the formula for 20c2? 20 factorial over 2 factorial times 18 factorial times 2 to the power of 18 times x to the 34. Let's just practice working it out. How would you work it out? 20 times 19 times 18 factorial over 2 factorial times 18 factorial times 2 to the 18 times x to the 34. You know why? In some questions, they're going to ask you to leave your answer in index form or factorial note, in simplified index form or factorial notation. Okay, so in some questions, you'll be asked to find the coefficient in factorial notation or in simplified index form. Okay, so we're just going to do that. What's going to cancel? The 18 factorials. You know, one of these 2's, all right, that 2 will make this at the top what?
Do you have to do like that?
Can we do? So now 2 goes into 20 10 times, so you do have the 190. Look, I suppose this one, if they don't ask you, just put it in your calculator, all right? Then you could work it out, I suppose. I mean, 190 is really 2 times something, isn't it? It's 2 times 95. If I want to write that in simplified index notation, is 90 divisible by 4? It's not. That's really 2 times 95 times 2 to the 18 times x to the 34. Look, I think the answer just wants a number, but if you had to do it in a simplified, if you had to do it in an index notation, I mean, the 95 doesn't help. But look, if you want if they just want the coefficient, just stick it all in the calculator, all right? Your answer anyway is, if you had to write it as a product of prime factors, that would be it. I'll show you. This is as a product of prime factors. So 2 to the 19, that's 2, is a prime number. 5 is a prime. Oh, because 95, isn't 120 times 5? So 95 would be 19 times 5. So if you had to write your answer as a product of prime factors.
Well, why did we have to break up the 190 in the first place?
But actually they do. It says find the term, give each coefficient as a numeral and factored into primes. As a numeral and factored into primes. So now that's factored into primes. So girls, what you would have done is over here, the 190 is 2 times 95, which is 5 times 19 as prime numbers. Do you see what I've done or not? The 190 is 2 times 5 times 19. Yes or no?
Yes.
All right, so that is giving my answer as factored primes. Okay, and then as a numeral, you can put it on your calculator, which is 49,807,360, x to the power of 34. So this answer is factored primes, answer as factored primes, and this is the numeral answer, giving the answer as a numeral. And that is the prime factorisation of 190, which you learnt how to do in Year 7. All right? Now you might keep going, and can you find the term? Can you now find the term in x to the minus 5? And see if you can do it as prime factors and whatever. So find the term in x to the minus 5. Do you know what you're going to do? We've got the general term. What do you do?
C.
No, it's B part 2. How do I do the term in x to the minus 5? 40 minus 3k equals negative 5. So 3k is, what's 3k? It's 45. Is that right?
Yeah.
And so k is 15. So to get the term in x to the minus 5. Now what do? We go back into the original. Hence the term in x to the minus 5 is 20c. You can see your general term somewhere on that paper. 20c what? 15. We've got 2 to the 20 minus 15 is 5. Negative 1 to the 15. X to the negative 5. All right, we want this as factored prime, so it's got to be simplified. So 20c15, 20 factorial over. You know what you're doing? I want it written as factored primes. What do we got? 20 factorial over. All right, you keep going. 5 factorial times 15 factorial times 2 to the power of 5. What's negative 1 to the power of 15? Times negative 1 then we got x to the minus 5. So we've got to simplify this 20 factorial over 5 factorial, 15 factorial into 20 times 19 times 18 times 17 times 16 times 15 factorial over, I'd be breaking down the 5 factorial. 5 times 4 times 3 times 2 times 1 times 15 factorial times 2 to the power of 5 times negative 1 times x to the negative 5. So we want to simplify that 20 factorial over 5 factorial, 15 factorial times 2 to the 5 times negative 1. You know what you're cancelling? The 15 factorials can go. 5 times 4 is 20. 3 times, 3 goes into, 3 goes into 18, and that becomes a 6. And we may as well, or we can put the 2 into the 8, it doesn't matter. So 2 goes into that as well, actually, and gives us a 3. So we're nearly there. Is 19 a prime number? So's 17. So's 3. 16 isn't. Isn't it 2 to the power of 4? Because I know it's 4 times 4, but they're not prime. So 2 to the power of 4 times 2 to the power of 5 times negative 1 times x to the negative 5. You're nearly there. So let's do it in order. When you write it as a product, so we did 5 times 4 cancelled with the 20. We had the 3 times 2 is 6. It went into the 18 3 times. And then we're left with 19, 17, 3. We're writing 16 as 2 to the power of 4. So what have I got? Start with the smallest number, which is 1. So that's going to be negative 2 to the power of, anything? 9 times 3 times 17 times 19, x to the minus 5. So that is writing my term as a product of factored primes. And then you can work out what it is. You should get minus 496,128 x to the negative 5. And you know what? You can just check it on your calculator. Oh, you're full. Okay. Should I? 6,128 x to the negative 5. Is it right? Yeah. Okay, girls, second example. In the expansion of x plus 1 on x to the power of 40, x minus 1 on x to the power of 40, find the term independent of x, give your answer in NCR form and also as a numeral. What do you notice about x plus 1 to the 40 and x plus 1 on x to the 40, x minus 1 on x to the 40? Do not do it your method yet, please. I don't want two binomial expansions multiplied by each other. It would be the biggest nightmare in the world. So, they're the same power. Good. So that is, all right, I'll just do it step by step. Because they're both to the power of 40, you can write them as x plus 1 on x to the times x minus 1 on x. Both are to the power of 40. Now, that is just the same as x, a plus b, a minus b. Oh no. Almost full. Pause.